let's go ahead and put some of this curve sketching knowledge to practice. In other words, what we know about the transformations, let's see if we can put that together and see how we would do some basic sketches. Now, first of all, we'll start off with a simple one. Let's suppose that we've just got sine x plus 7. Okay. Now, notice that with this function, there is nothing to change the period or the amplitude, right? Because there's nothing in here with the x being multiplied, and there's nothing on the outside being multiplied. There's nothing being multiplied, so there's nothing changing the shape. This thing is going to have just the same shape, and that's right, it's going to shift up. That's it. That's all that's going on here. All that we have going on is this one vertical shift. So what I would recommend is just go ahead and I'm going to take this approach. I'm going to just look at this, and you won't need to do this as much now, but what I'm going to do is start having you make a little box when you graph these trig functions. And just put your sine graph in there and then fill in the parts. So for example, where does this graph start? 0. And it ends at 2 pi. Now we know that because it's not been stretched or anything. Now, here's what we need to figure out. What is this line right here that the sine is being oscillated about? What is that line? Let me put 0. That's right, it's 7. Okay, so it's 7. And I'll put the 2 pi down here. Okay, so this graph is oscillating about 7. What is this high point up here? 8, that's right. And what about down here? 6, that's right. So that's very simple. All we have to do is look and see what that vertical shift is. That's how high up the graph is shifted. And then we can figure out from the amplitude how high up it goes from there and how high from there, or how low from there. Do you see that? Okay. So you can see here the amplitude is 1, the period is 2 pi, just like usual. Nothing has changed as far as the shape goes. All we've done is just raise this graph up a little bit. Okay. Now let's take a look at another one. Let's suppose that we've got y equals 3 sine x plus 2. Okay. Now, first of all, what have we got going on here? What kind of vertical shift? That's right, we go up 2. And what about the amplitude? What is the amplitude? That's right, 3. Now, so what I would recommend is just go ahead and making your box. Although you don't have to, but this might come in handy, like I say later on. We'll just make a little box, and I just put the sine function, just put the sine graph in it, just a quick sketch. Now, this graph, notice horizontally it has not been messed with. It still starts here at 0 and goes to 2 pi. Still starts at 0 and goes to 2 pi. Now, what is this line about which it's being oscillated? 2, that's right. So it goes 2. Now, how high up does it go? Notice the amplitude is 2, so it goes. Actually, the vertical, the amplitude is 3, so it goes up 3, so that's going to be 5. How far down does it go? It's oscillating about 2, and it has an amplitude of 3, so how far down does it go? -1. Okay. See? So it goes all the way down from -1 up to 5. Does everybody see that? So look what we have. We know how to deal with vertical shifts, and we know how to deal with change in amplitudes, or just some basic ones. Any questions about that? Okay, now let's go to the next step and see what we have. Okay. Now, what's going on with this function? It's a horizontal shift, which way? To the right. That's correct. You know that it's in there with the x, so it's going to go the opposite of the way you might think at first. Before you really look and see what's going on, you might think, well, that should be to the left. But no, you remember, it's to the right. So we've got a shift to the right. So here's what I recommend. And other than that, we don't have any shifts, right? So let's see what we've got here. Now I'm just going to make my box. Every time I make the same box, and I'm going to just go ahead and put the sketch in. Now, the art part of this is going to be in the labeling. In other words, I just draw the graph in there, and then I'm going to label around it. That's the approach I'm taking. So we know that this thing oscillates about 0, and it goes up to 1 and down to -1, right? But what is changed here is the starting and the stopping point, right? Where does this graph normally start? Normally it starts at what number? At 0, right? But we're shifted to the right pi/6 units, right? But we are shifted to the right pi/6 units. Right? So now look and see where we start. We start here. We go 0 plus pi/6. So where are we starting? Pi/6. So this point right here is pi/6. We're not starting at 0. We're starting here a little ways to the right at pi/6.
That's just what we do. We just draw an arrow to it and say that's what it is.
For right now, this is the technique right. Notice all I'm doing here, Paul, is just labeling it.
Okay.
And then I can always transfer this to a graph. Okay, so we know it starts at pi/6. Now, where does the graph end? Yes, 2 pi plus pi/6. So this graph ends at 2 pi plus pi/6. Now what we want to do is write that out exactly what that is. We don't want to have a decimal representation. We want to write out exactly what that is. That means we need to add these. This is going to be what? 12 pi/6 plus pi/6, right? Is that right? So what's that going to be, 13 pi/6? Don't let me misadd now. Okay? So here we go. We got 13 pi/6. So look, the graph has the same, the basic amplitude of 1. It oscillates about the x-axis. However, it's been scooted over so that it starts at pi/6 and ends at 13 pi/6. Any questions about that? Everybody see that? Isn't that wonderful? Any questions? So notice what we're doing is we're taking these graphs part by part and constructing what their graph looks like. In other words, we're taking the functions part by part and constructing what the graph looks like. And in a minute, we'll look at just a general sine function with the unknown parts. Okay, now let's look at this. Let's suppose we've got y equals 3 sine x minus pi/3 plus 2. Now, this one has a lot going on, right?
So it's amplitude 3, it was moved to the right, then...
Yeah, so that's right. So let's just see if we can do a quick sketch. Now remember, the idea here is so that we can look at these and immediately tell roughly what they look like. Of course, you could argue, well, why do I need to know how to do this? Because I can put this in my calculator. But the idea is you're developing, sort of like learning your times tables. You want to be able to just look at this and have an understanding of basically what's going on. You don't want to have to be tied down to your calculator, because oftentimes before you plug into your calculator, you can have this figured out. So let's see here. Let's just see what this sketch looks like. So I'm just going to do the basic sine graph. Okay, there it is, basic sine graph. Now I'm going to fill in the parts. First of all, the first part that I go to that's the easiest is this number on the end. This number right here. This is the D. And I always talk about when you're graphing these to start off with the D and A. The D and A, that's the building blocks for these graphs. You get the D first and then the A. And we're going to learn that typically the coefficient is a placeholder is A, and the number here on the end is the D. And we'll see that in just a second, but get the vertical shift first, then get the amplitude. Now the vertical shift is 2, so just put a 2 there. That's the graph about which, that's the line about which your graph is oscillating. Now your amplitude is 3, so that tells you what the high point is. What's the high point? 5, and what's the low point? -1, okay? We got those. Now we're almost finished. Where does this graph start? Pi over 3, that's right. It starts at pi over 3, and where does it end? 2 pi plus pi over 3. So that's going to be what? 6 pi over 3 plus pi over 3, which is 7 pi over 3. So it looks like this graph goes from pi over 3 to 7 pi over 3. So notice how fast that was. All you do is see it oscillates about this, it goes up 3, it goes down 3, and it shifts over to the right pi over 3 units. You'll see how fast you can do that. By the time you would have put that in your calculator and make sure you're in radian modes instead of degree modes, you could have, If you can put this in your calculator and graph it. The thing is, this one was more trouble than it was worth to put in your calculator. It's sort of like if I ask you what's 4 times 5. It's more trouble than it's worth to pull out your calculator. This graph is more trouble than it's worth to try to pull out your calculator and graph it. I mean, it's easy. Because look, every time you enter it in your calculator, you're taking a risk. Maybe you're in the wrong mode. Maybe you'll forget to close the parentheses. There's all kinds of things can go wrong. But, of course, there's things can go wrong anyway. But it helps if you have an understanding about what's going on. Any questions about that? Okay, now let's look at something else, and then we're going to put everything together, all the whistles and bells. Let's suppose that we've got y equals sine 4x. And we haven't done one like this in practice, for practice yet. We've looked at an illustration of sine 2x. But now, this does something to the graph horizontally. It changes the shape of the graph horizontally. That's right, it squishes it. In other words, this sine 4x gets through a graph, a period, a 2 pi cycle, 4 times as fast as sine x. It gets through it much more quickly. So let's go ahead and let's just look at just one period of this graph. Just like usual, we'll go the same old, use the same old process. And that process being just going to graph it. Now, notice I haven't labeled anything. I'm just looking at one period of this graph. Just one period. Now, we know it oscillates about the x-axis. It goes up to 1 and down to -1. What's in question here is where does it start and where does it stop? Now, it has not been shifted to the left or right. So where does it start? 0. That's right. It starts at 0. However, when does it get through one complete cycle? That's right, pi over 2, because it gets through it 4 times as fast, right? Now here's the way you can always determine that. Take this 2 pi and divide by the 4. Okay? In other words, every angle, if you wanted to know what the translated angle is, just divide by the 4. So this is just going to be pi over 2. Okay? So this graph, sine 4x, gets through a complete cycle in pi over 2 units. See? Now notice all I did, I just took the 2 pi and divided it by 4. Does everybody see that? Okay. Now, let's put this together with one, or everything we've done so far, let's put one together that has everything. And let me make this a, let me just... Okay, now let's look at this one. This is what I call having all the whistles and bells. It has vertical shifts, it has horizontal shifts, it has amplitude change, period change, vertical shift, horizontal shift, amplitude and period changes. Okay. Okay. So let's just make, now this technique that I'm showing you, I don't know how commonly used it is, but I find it's helpful if you can just make a little box, and it kind of helps you keep things from getting too much out of hand. When you're it's easy to get a lot of numbers going all over the place. This might help you a little bit. So what I'm going to do, I just make my sine graph, and then I build my labels around it. Now, first of all, I know this oscillates about 7, and it has an amplitude of 2, so this would be 9, and this would be 5. See how easy the vertical is? Very easy. Now, the next thing, we've got to take care of 2 things that are going on inside the sine function. One is I'm multiplying by 2, and the other is I'm adding pi over 4. Well, here's what you do. I'm going to illustrate this with 2 numbers. I'm going to illustrate with 0 and 2 pi, and I want to illustrate what's going to happen on this transformation. Here's the process. I'm going to divide by 2 and add the c. Because sometimes the question is, well, what order? Well, this is the order. Okay? So notice, I divided by the coefficient, and then I added this thing right here. I keep referring to it as c. I realize I haven't given that to you yet, but I divide by this number and add this number. Now notice, I divide by this number and add this number. And this takes care of the transformation. Both horizontal transformations. So now this one is easy. This one's just pi over 4. So this graph starts here at pi over 4. Now let's look at this one here. Is this going to be 5 pi over 4? Okay, I think you're right. You'll see how she did that? She said, well, I need a least common denominator of 4, so multiply the top and the bottom by 2. This is 4 pi, and there's 1 makes 5 pi over 4, so 5 pi over 4. So it ends at 5 pi over 4. Now there's our complete graph. Okay, everybody see that? Any questions about that? Okay, now let's just look and see what we have here. Let's look at all the whistles and bells in a general form. We've got A sine B times x minus c plus d. This is what we've been graphing. Okay? This is what we've been graphing all along. And remember, you have, of course, D is the vertical shift. Okay. A, the absolute value of A is the amplitude. Okay. Because that's important, because if you have like a -2 in front of sine, that's not the amplitude. The amplitude would just be 2. So the absolute value of A is the amplitude.
Would the negative have effect on anything?
Sir?
Would the negative have effect on anything?
If it was negative, it would have the effect of turning the graph upside down. It would flip it over from what you're used to. So it would be that kind of transformation. Now, a couple other things I want to point out to you. Let's just look at this B. Now, remember that the period, let's just think about this. Okay. If we talk about the period of the graph, remember how long it takes to make a complete cycle. Well, remember earlier we said when we had like 4x, we said, well, it took pi over 2 to make one complete cycle, right? Well, for that graph, sine 4x, the period was pi over 2. In general, if we want to find the period, we take 2 pi and divide by b, and that will give us the period. In other words, we can use b to determine the period of the graph, because the b dictates how fast the graph goes through, how fast the graph, or how compressed the graph is. Well, if we take the normal period, divide by b, we'll get the new period. Okay. Yes, ma'am.
Okay, so like, if you know how we did the last graph.
Okay, now the third thing is C is equal to phase shift. It's called the phase shift. It's the horizontal shift. And you don't have to, what you know about the phase shift already, or about the horizontal shift will serve you well. So if this were x minus pi over 3, you know you go pi over 3 units to the right. If it were x plus pi over 3, you go that far to the left. Okay. Does everybody see that? Now notice the fact that I do have in this general form the negative up here. Okay. So if this read x minus pi over 3 and I said what's the phase shift, you would say pi over 3. If it said x plus pi over 3, the phase shift would be negative pi over 3. If you were just asked what the phase shift is. It's because this is given to you in the negative form there. Okay? Any questions about that? Now, look, when finding a transformed angle, when the angles have been transformed, here's what we need to do. Okay. So, when finding a transformed angle, okay, here's what you need to do. Divide by b and add c. Okay? Divide by b and add c. So here it is. Divide by b and add c. That's what you need to do when finding a transformed angle. Okay? And you have this general form. Okay, so notice, you have your basic sine x. The D tells you how far up it shifted. The A tells you how far up from that shift you go to the top and then down to the bottom. That's the amplitude. The period lets you know how many cycles, how many complete cycles you're going to have in a 2 pi period. Or it tells you how long it's going to take you to have one cycle of your graph. You take the 2 pi, divide it by b, and that tells you where the end point is of your of a period, if it starts at 0. or from its starting point to where it completes a full cycle. That's how long it's going to take. And of course, C is the phase shift. Okay? Any questions about that?